Today, we're going to talk about another important concept that is called the mass of a mole. Okay, this is what we concluded at the end of our last lecture. The relationship between a mole, the Avogadro's number, and the mass of 1 mole of a substance. We learned that the mass of 1 mole of a substance is the same as its formula mass numerically. They just have different unit. The formula mass has a unit that's called AMU. The mass of 1 mole of something, the unit is in grams. However, given the formula, you will get the mass of 1 mole like you do for formula mass. Okay, here is the example we talked about last time. If they are asking you to do the mass of 1 mole of a substance, given formula, you would just use the atomic mass of each atom, 1 silver, 1 nitrogen, 3 oxygen, add them together like you do for formula mass, and make sure the unit is in grams. That's the mass of 1 mole of something. We also learned that there are actually 6.02 times 10 to the power of 23 particles in 1 mole of some particle. Okay, that number is called Avogadro's number. So 1 mole means diameter particles. Diameter particles means 1 mole. Now let's move on. Here is today's topic, molar mass. Molar mass is the mass of 1 mole of something. Oh, we know this. We were talking about this the whole last episode. And we just did the calculation of the mass of 1 mole something on the last slide. So we just given a formula, we just use the atomic masses for all the atoms in the formula, add them together, that will be the molar mass now. Just make sure to change the unit to grams per mole. Molar mass is grams in 1 mole. So grams per mole. Molar mass of nitrogen, 14.01 grams per mole. That's the unit of molar mass. Molar mass of water, 18.02. How do you get it? 2 hydrogen plus 1 oxygen. Molar mass of barium nitrate. How do you get it? 1 barium, 2 nitrogen, 6 oxygen. Okay, not a big deal. We know how to do that. Molar mass is a conversion factor, isn't it? Of course it is. Okay, it is a ratio. Look at the unit. It is a ratio of 2 different units. A ratio of 2 different units is a conversion factor. When did we learn that? We learned that in chapter 2, dimensional analysis. Then what are the 2 units it converts between? All right, it converts between grams and moles. Back and forth. When the grams of something is given and moles is wanted, or moles of something is given and grams is wanted, you need the molar mass as the conversion factor. Here we are. At the beginning of chapter 6, I said that this chapter is full of calculations. Well, there are actually 3 kinds of calculations. They are related, but they are getting more and more complicated. Here is the first one, calculation based on 1 substance, conversion among mass, moles, and the number of particles. What is this? Okay, I have this flow chart put here. We are going to use this flow chart every time we do calculation on this conversion between mass, moles, and the number of particles. Try to use this flow chart when you practice by yourself. It will help you a lot. All right, so what it says here, what we can do is if grams of something is given, we can get moles of something back and forth. Given moles, we can get grams. Given grams, we can get moles. What do we need? The conversion factor we need is the molar mass to go between moles and grams back and forth. And depending which one is given, which one is wanted, the molar mass will be set up differently. In chapter 2, you know that each conversion factor can be written in two different ways, depending which unit is wanted, which unit is given. Then, from moles and the number of particles, you can also convert between number of particles and moles. They may give you the moles of something and ask you how many molecules are there in 2 moles, for example. How many atoms are there in 1 mole of something? Well, what we do know is that in every 1 mole of a substance, you have Avogadro's number of that substance. So given moles, by using Avogadro number as a conversion factor, you can get a number of particles. Given number of particles, again, by using Avogadro's number as a conversion factor, you can get moles. And again, depending on which one is given, which one is wanted, there are 2 ways to set up the conversion factor. All right, we are about to practice doing this. Let me remind you, question given, make sure you have this flow chart in front of you. Then after that, your first job is to map the question to this flow chart and then starting your setup. What do you mean by saying map the question to the flow chart? Let's do it together. Calculate the mass in grams of a 2.5 moles of sample of ethene. Ethene, the formula is given. Once we know the formula, we can calculate molar mass. We know that. All right, so let's map this question to the flow chart. First, which information is given? The given information is moles of something. So we know we are here right now. We are in moles. We know moles of something. Then let's see where the question is asking us to go to. What kind of question is wanted? It is asking to calculate the mass in grams. Oh, grams is wanted. The mass, this box, question about the mass is wanted. Once you know that, this flowchart tells you clearly to go from moles to grams, you need only one conversion, and the conversion factor will be the molar mass. So let's set it up together. We will follow what we learned in chapter 2, dimensional analysis. All right, you start your setup by providing the unit of the given information. We know what we know. The unit of given information is we know moles. We know moles of what? Moles of ethene, C2H6. We know this. Then let's identify the wanted information. The wanted information will be on the right of the equal sign. That's what you want to do to get. Is it going to be grams of something? Grams of what? Grams of ethene, of course. So grams of ethene is wanted. Now in chapter 2, we learned that once you identify the given information, wanted information, if they are different, then you know you need a conversion factor. The conversion factor needs to be set up in such a way that the unit of given information needs to be at the bottom. The unit with wanted information needs to be on the top. Now let's put in all the numbers. Given information 2.5 moles. This conversion factor, well, it's not given. The question didn't say anything about this. Well, you don't need it tells you, because you know the flowchart tells you, you know you need the molar mass. Okay, the conversion factor here to go between moles, mass, moles, back and forth. you'll need molar mass. Now, molar mass, given ethene, we can do that. 2 carbon, so 2 times 12.01, 6 hydrogen, 6 times 1.008. 2 of that, 6 of that. That is going to be 30.068. So 30.068 grams per mole. Now, where do I put 30.068? On the top or at the bottom? Of course, on the top. On the top, it says grams. Your molar mass is grams per mole. In front of mole, it's always going to be 1. In front of grams is the number you calculated. All right. Now, when you do calculation, you start your starting number, multiply it by the number on the top, divided by the number at the bottom. On your calculator, if you punch all these numbers into your calculator, you are going to see 75.17 on your calculator. Now you have to make a decision. How many sig figs do I keep? You keep 2 sig figs. The given information gives you only 2 sig figs. This number has 5 sig figs. So you keep 2 sig figs in your answer. The answer will be 75 grams of ethene. So let me review what we did again. We look at the question. We identify in which box from the flowchart, in which box we know information, and we identify which box is our destination. In this case, we are right here in the moles. We want to go to mass. Once you know this, you know you need only one conversion factor, and that conversion factor should be the molar mass of ethene in this case. Then you set it up, starting by the given unit, followed by the wanted unit, and set the conversion factor up correctly. Is it grams on the top or grams at the bottom? Depends. Actually, in the flowchart, I provided that for you. If you're going from moles to grams, this is the conversion factor you need to use. Grams will be on the top, moles at the bottom. If you're going from grams to moles, this is the way you're going to use the molar mass conversion factor. Mole will be on the top, grams will be at the bottom. All right, here's another practice. Try to follow the steps or the pattern we did and do it by yourself. We keep moving on with our lecture. Still here, we're going to use this flowchart again one more time, a different kind of example. This time, calculate the number of molecules. Oh, we want the number of particles. Here is our destination this time. We want to go there. Calculate the number of particles of a 1.5 moles of sample. What do we know? We're in this box. We still know the moles of something. We need to go from moles box to the number of particles box. How many conversions? How many steps? Of course, one conversion. What is the conversion factor? Avogadro's number is all labeled out for us. So let's set it up. Given unit, we know moles of something. In this case, again, we're using ethene as example. We know moles of ethene. We want the number of molecules. Okay, we want molecules of ethene. That's what we want. If that is the case, guaranteed we need a conversion factor. The conversion factor needs to be set up in such a way that the given unit needs to be at the bottom, moles of ethene. The wanted unit needs to be on the top, molecules of ethene. All right, now let's plug the numbers in. The given information is 1.5 mole. Okay, now Avogadro's number, this conversion factor must be the Avogadro's number. Now, Avogadro's number on the top right now, in this case, on the top is the number of particles per mole at the bottom. So 1 mole, 6.02 times, 6.02, 6.02 times 10 to the power 23. This would be your setup. 1.5 times that divided by 1. And you again, in your answer, you need 2 sig figs. That will give you 9.0 times 10 to the power 23. On your calculator, it should be 9.03, but you need to keep 2 sig figs. So 9.0 times 10 to the power of 23 molecules. Again, a practice. You can try to set it up. This time, it asks you to go from number of molecules to the moles. Okay, number of molecules is given, moles is wanted. Let's move on. Another practice. Calculate the number of molecules. Okay, again, this is our destination. This is where we want to go to. Of a 9.01 grams of water sample, or we know grams of something. We're here. Right now we're here. We need to go to number of particles. To go from grams to number of particles, there's only one way to go. You need to go through moles, then go to particles. So you know you need 2 conversion factors. The first one will go from grams to moles. This is number 1. From grams to moles. The second one will go from moles to particles, molecules in this case. Okay, let's set it up. So, given unit, grams of something, grams of water in this case. Finally, it wants us to calculate the number of molecules. So molecules of water, that's what is wanted. And from the flow chart, we know we need 2 conversion factors. We'll have to do conversion factor twice. The first one will go from grams to moles. The first conversion factor, by the end of first conversion factor, we're going to convert from grams to moles. So given unit at the bottom, final target moles, the first stop moles on the top, so mole of water. We haven't put in any numbers yet, but we know regardless what the numbers we put in, eventually by the end of step number 1, we're going to get a number whose unit is going to be moles of water. By the end of step number 1, we will be in this moles box now. Now, step number 2, we're going to go from moles to number of particles. From has to be at the bottom. You're going from moles to the final destination, molecules of water. Particles are molecules in this case. Now let's put all the numbers in. The given number 9.01 grams. What is this? Well, this is the conversion factor to go from grams to moles. The flowchart tells you it must be the molar mass. All right, molar mass of water, 2 hydrogen, 2.02, 1 oxygen, 16, that's 18. Molar mass of water will be 18.02. Now, 18.02 grams per mole. Grams this time at the bottom. See how to put 18.02 at the bottom, 1 mole on the top. What is this then? This is the conversion factor on the second step of the conversion, which is Avogadro's number. Avogadro's number is how many particles in 1 mole. So mole at the bottom right now, 1 here, 6.02 times 10 to the power of 23. All right, if you punch all these numbers into your calculator to keep 3 sig figs in your answer, because the starting point has 3 sig figs, you are going to get 3.01 times 10 to the power of 23 water molecules. I hope you are following me right now. Here is another example. You can try to do it by yourself. Again, this one goes backwards from particles to grams. 2 conversion factors are needed. See you next time.